Okay, now let's take a look at how do we solve this printing two non-repeating integer problem. So if there was only one number like 7, let's say imagine 9 is not there in this array, then solving this problem is easy because we have done a similar problem called finding Akela, and the property that we can use is that of XOR. We could have done XOR of all the values, and we know the XOR, what XOR does is XOR cancels out the similar numbers. So 2 XOR 4 XOR 2 can also be written as 2 XOR 2 XOR 4. Ideally, we can do this XOR operator is similar to addition. So ideally, if we do this first or this first, or we do 2 XOR 2 and then we do XOR 4 first, answer to everything of them will be the same. So that's why, like here, 2 will be cancelled, which will become 0, and 0 XOR 4 is always going to be 4. So XOR has this property of cancelling the similar numbers. But this problem, and in fact this is a Google interview question, and this problem says there are two numbers which are only uniquely existing only one. They are not repeating numbers. So how do we find that out? So answer here also lies in the XOR operator. Let's do XOR of all these numbers together, and what we get eventually is we get the answer of 7 XOR 9 as the answer. So first we are talking about, let's do an XOR all, and when we do XOR all, and let's say that is answer. So answer in this example in particular, if we talk about, is 7 XOR 9. That is what we are going to get. And now our challenge is how do we segregate these two numbers. Now to segregate these two numbers, one thing we can derive from this answer is, if this answer in this example, if we look at 7 is 111 and 0 triple 1 and 9 is nothing but 1001. So if we do XOR of these two, then what we are going to get is 1 1 1 0. So 1 1 will become 0, 0 1 will give us 1, and this 1 0 will give us 1, and 0 1 will give us 1. So we have reached this point. Now if we have this XOR all answer, and this answer's last set bit 1 is telling us that this bit is different in 7 and 9, and we can conclude that, like, in 7 this bit was set and in 9 this bit was not set. That's the reason we are getting 1 here. Now based on this bit, if we try to differentiate all the numbers of the array in two groups, one group where this bit is set will numbers of that group will go here. So we can say last bit set, or not last bit, first bit set, which this is 0th bit, this is first bit set numbers will be one group, and first bit unset will be another group. And let's see how do we differentiate or segregate into these two groups. So what we will do is, we will first create a mask out of it, and that mask will apply to each and every number. And we know the formula to calculate mask is, it was mask will be equal to a ampersand minus a. That will give us a mask. So a is nothing but this number, minus a is nothing but, negative number is nothing but 1's complement plus 1, that's 2's complement. So one complement of this number, if we say, will be, all 1 will become 0, all zeros will become 1. So this is the 1's complement, and we add plus 1 to it, that will give us the negative number. So if we add 1 here, this last will become 0 and this will come 1. So negative value of this number will be this. So now if we do ampersand of these two, then we will see, we will be coming up with a mask 0010. So this is what we are talking about. Mask means keep the last set bit as it is, rest all makes 0. So now we have received the mask. This mask will help us divide these numbers in two groups. So we will write a loop over this array, and we will keep doing a bitwise AND of this mask with every number. So we will say for I0, I less than n, I plus plus in this array, what we will do is, we will apply mask. We'll say if mask ampersand ARR of I some numbers will become 0, because if this bit is not set in those numbers, they will become 0. So this gives us the first group numbers. Else the number falls in the second group. Now let's see which number will fall in first group, which will fall in second group. 2 is nothing but, the binary form of 2 is, here we will write 2 is nothing but 0 1 0. So this is 2. If we multiply this with mask, mask is also the same, so we will get one value, so it will not go to the first group. 2 will land up in the second group, so we can put it here. 2 will come here, whose value is 0 0 1 0. Now we apply the mask in this loop to second number 4. 4's bitwise value is 0 1 0 0. So if 0 1 0 0 we do bitwise AND with this, 4 will land up in the first group. So 4 is 0 1 0 0. So this is 4. So 4 is landing in first group. 7, if we apply this mask, so 7 was this. So if you multiply this with the mask, you are not going to get a 0 value, because this one will keep it something above 0. So this is also non-zero value, so non-zero will come to the second group. So 7 lands up here. Then we apply that to 9. 9 we see this is 9. 9, if we do ampersand with this mask, it will become 0. So 9 lands up in the first group, because 9's value was 10001. That is 9. Same we apply to 2. 2 will land up again in the second group. 4 will land again in the first group. So if we look at applying this trick, calculating the mask, applying the mask to segregate the number in two separate groups, then we end up differentiating our array into separate groups, and these unique numbers have fallen in the separate group. Now how do we figure out these numbers is, if you keep on doing the bitwise XOR of all the numbers of the first group, all the numbers of the second group, you reach to an answer. So that is the hint to solution. You can pick up this hint and you can solve this completely. If you are still not able to get it, then there is a solution video also available.